Hello, my friends. Today we're going to be solving an arrow Sudoku called Collisions. This is by Philip Newman, and it was originally posted in GAS on March 12th, 2024. So we have standard Sudoku rules, so we are placing the digits 1 through 9 once each in each row. Ooh, that went a little wild there. Each column and each heavily outlined 3x3 region. And then we also, on top of that, have arrow Sudoku rules. So we have some arrows in the grid, and each arrow has a circle attached to it. And the rule says that the digits along the arrow have to sum to whatever the number in the attached circle happens to be. And if there's a circle that has two different arrows attached, then each of those arrows independently has to sum to the circle. So if this circle had, say, a 5 in it, these two cells would have to sum to 5, and so would these. Now, when you're doing arrow Sudoku, there are two numbers that whenever you see them as the arrow bulb of a 3-digit arrow, only have one possible way that they can be formed, assuming that all of the digits along the arrow are able to see each other, and those are 6 and 7, which are already in the very top row of this puzzle. So 6 with 3 cells is always 1, 2, and 3. There's no other way to make it, that's the minimum. And then 7 is just 1 greater than the minimum, so that is 1, 2, and 4. Now 9 and 8 have a couple of options each, so we're going to leave those for now and we're going to come back to them when we know a little bit more elsewhere. So right now let's keep looking at the top row. So we have to put 9 somewhere in this top row. And it can't go along an arrow because then we would have to have a digit in the arrow bulb that was greater than 9. So 9 can only go in this bulb here. And now if we consider 8, 8 could technically go on this arrow, but it would have to be paired with a 1, and we've definitely already used a 1 in the row. So the only remaining position for 8 is there, which puts a 1 here, eliminates 1 from these cells, and gives us a 1 here. Now our two remaining digits in the row are going to sum to 9, and they will be 4 and 5. So now let's kind of work our way around the grid clockwise. And let's look at what we can place here. So we still need 3, 5, 6, and 9 in these cells. Those can't be 5 because there's a 5 in the region. They also can't be 9 because you can't put a 9 along an arrow because that would create a sum that was greater than the maximum digit allowed in a Sudoku. So that's got to be 3 and 6, which means their sum is 9, and that is a 5. So where to next? So this 8, there are two ways to form a total of 8. We could go 1, 3, and 4, or 1, 2, and 5. The only part of that you might want to remember is that they only involve digits from 1 to 5. So we can pencil mark in 1 through 5 there. And we know that the 1 can't go there. There has to be a 1, so it's in one of those two cells. Now that's not restricted yet. I do see a couple of things that are a little more restricted that will kind of work together to help us figure out what exactly goes along that 8 arrow, and one of them is this 5. Now that this 5 arrow sees a 1, the only way we can form a total of 5 is to have it be 2 plus 3. So let's put a 2, 3 pair there, and that's going to give us a 4. So now if the 8 already has a 4 in it, the other two digits are 1 and 3. So we can go ahead and place those there as a pair. And then the other thing that jumps out at this point is the 6 sum. It sees a 5, and now how do we make 6? We could go 1 plus 5, or we could go 2 plus 4. In the middle, 3 plus 3, can't do it because that has the same digit twice, and these two cells see each other. So this must be 2 plus 4. And because of this 4 in the region that we just placed a moment ago, we know which way around that goes. This column is starting to also get pretty restricted, so let's work on this for a moment. So we need to place a 9 in the column. Because of this 9 here, it can't go in those cells. So here's my 9, and then I need to place a 6 and a 7. Now one of those fell along the 9 arrow, so we're going to have this 9 be either 6 plus 3 or 7 plus 2. Can't be 7 plus 2 because we've already used 2, so that's going to be 6 and 3. And we can finish the region. So now let's keep working clockwise. So here we need a 7 somewhere in this row. It's the biggest remaining digit that we haven't accounted for yet. So it can't go along this arrow because if it did, then this number would have to be bigger than 7, which at this point is impossible. So there's our 7. To make a sum of 7 using none of the digits we've already placed, we have to go 2 plus 5. And our one remaining digit is a 6, which places a 1 here. Now it's time for a little bit of cleanup. So we have a 4 here, which resolves this 4 and 5. We've got a 1 looking at the 7 arrow, so this is either 2 and 5 or possibly 3 and 4. But we can't have 4 or 5 in this cell. So that's either 2 or 3, and that is going to be 4 or 5 for now. A little bit more Sudoku down at the bottom here. This 9 sees these 3 cells, so we're going to have to place it here in order to get 9 in this region. And the 3 remaining digits in this region are going to be 1, 7, and 8. 7 is eliminated from this cell, so this is 1 or 8. Now, I don't think you're necessarily going to have to use this while solving. I think it's kind of cool, so I'm going to point it out. This is a 1 or an 8, and the thing is, if it's a 1, this cell has to be an 8. And if it's an 8, this cell has to be a 1. So no matter which order they go in, this is going to be a pair 1 and 8. So we can mark it like that. Let's look at this row. This is getting pretty crowded at this point. So this needs a 3 and an 8. We definitely can't put the 8 here, because then we would have to make this way too big to sum to 9. It would have to be at least 8, 1, and 2, which is already 11. So that's got to be our 3, and that's our 8. Now along here, our 3 remaining digits are 2, 4, and 5. We can't put a 4 on this 8 arrow because 8 is 4 plus 4, which is against the rules of Sudoku. And we actually can't put a 2 there either because the 6 is already here. So we can't have 8 equaling 2 plus 6. So it's 5 plus 3. So now that leaves us with this 9 being 3 plus either 2 or 4 plus something. Okay, well, what is that something? So 3 plus 2 is 5, which leaves us with a remainder of 4. 3 plus 4 is 7, which leaves us with a remainder of 2. So we have that same situation that we just had over here with this 1-8 pair, except this time it's similar but a little bit different. It's with a 2-4 pair in these positions. And by the way, this 3 that we placed a moment ago also resolves that 3 and 6, and the 3 here resolves that 2 and 3. That's been available for a while. I'm sorry if you were screaming at your screen about that one. So let's continue working around here. So just like we started out going clockwise, let's kind of carry on that pattern. And in this column, we're going to still have to place 1, 5, 7, and 8. No 8s here. That certainly can't be a 1, because you definitely can't make 1 by summing multiple other digits. And so now let's consider what the possibilities are for this sum. So this can't be a 5. We can't make 5 as what, like 1 plus 7? There are no possibilities there that sum to 5. It also can't be 7, because there are no pairs here that sum to 7. The only way we can possibly use 3 of these 4 digits to make a valid sum is going to be if we go 8 and then 1 plus 7 there. That makes our remaining digit here a 5, which places a 4 and a 3 and a 2, and gets us a lot of stuff in this row. So now I want to make a sum of 8 here. I can't use a 3 in it. I also can't use a 6 in it. And that actually narrows us down to just one possibility, 1 plus 7, because the 3 ways to make a sum of 8 are going to be 1 and 7, 2 and 6, 3 and 5. So this has got to be 1 and 7 in this order, which rules 1 out of these cells, and places a 1 for us right here. And our last digit in this region is a 9. This 3 straightens out this 2, 3 pair. And here we have a 4 to finish out the column, and that resolves that 2 and 4. Now we can use this 2. It's on a 9 arrow, so we have to place a 7 here. And that tells us where 7 goes in this region. It can only go right there. And we have so much now that we should be able to get a lot out of just doing a little bit of Sudoku at this point. So we need 5 and 6 in this region. We know which way around those go because of the 5 here. We need an 8 to finish off this row. We need a 2, a 6, and a 9 to finish region 2, and we already have 6 and 9 in this column, so that's going to be a 2, and that 2 will resolve this 5-2 pair. Our last digit in column 5 will be a 3. The 1 over here resolves this 7 and this 1. These are going to be 5, 6, and 9, and we already have 5 and 9 in this row, so that now becomes a 6. And now let's stop ignoring this for a moment. We have 3 more digits left to go in the row. They're 2, 4, and 7. Well, the only 2 of those that sum to 9 are 2 and 7, and the 7 tells us which order they go in. So that's our 4 for our last digit in the row. Now we've got an 8 here because of the 1 in the column, and that will resolve this 1 and 8. The 9 here tells us which way around the 5 and 9 go. We need to finish region 6 with a 4 and an 8. We can finish this using the 9 down here. And we just have 3 cells left to fill. This is a 1, it's the last digit in row 6, and we need a 5 and a 6. And that's how you solve Philip Newman's collisions. I hope you enjoyed that. I thought that was a really elegantly designed puzzle. I enjoyed kind of traveling clockwise around the grid, but just taking these occasional little digressions into the middle of the grid to make more progress elsewhere. I thought that was a really elegantly designed solve path, and I enjoyed that one. Let me know how you did in the comments. I look forward to hearing from you guys, and I will talk to you next time. Bye-bye.